Hello, friends. Welcome to Nexus, a smart buildings technology podcast for smart humans. I'm your host, James Dice. If we haven't met before, I write a weekly newsletter on this same topic. It's also called Nexus. Each week, I share what I've learned, my opinions, and what I'm excited about in the quickly evolving world of intelligent buildings. Readers have called Nexus the best way to stay up to date on the future of this industry without all the marketing fluff. You can check it out and subscribe at nexus.substack.com or click the link in the show notes. Since starting the Nexus newsletter, many of you have reached out to me wanting to talk shop, and we have. After a few weeks of those wonderful conversations, I realized I needed to record and share them with our growing community. So here we are. The Nexus podcast is born. This is our chance to explore and learn with the brightest in our industry together. One more quick note before we get to this week's episode. I'm a researcher at the National Renewable Energy Laboratory, otherwise known as NREL. All opinions expressed on this podcast belong solely to me or the guest. No resources from NREL are used to support Nexus. NREL does not endorse or support any aspect of Nexus. Episode 13 is a conversation with Deepinder Singh, CEO of 75F. I walked away from this conversation even more excited about 75F than I already was. As I've said before, 75F and Passive Logic are the only two companies I know of doing the blank sheet of paper approach to modernizing and improving the performance of building control systems. We unpack 75F's founding story, what makes them unique, and why they decided to create the whole stack rather than just an overlay. We talked about their over-the-air sequence upgrades, how they're similar to Tesla's, and how they enable the new epidemic mode for minimizing the energy penalty that comes along with the increased ventilation recommended by the CDC and ASHRAE to prevent the spread of COVID-19. Finally, we talked about their software platform, what makes it unique, and their hardware layer, and what makes it unique. This episode of the podcast is directly funded by listeners like you who have joined the Nexus Pro membership community. You can find info on how to join and support the podcast at nexus.substack.com. You'll also find the show notes there, which has links to Deep's LinkedIn page. Oh, and by the way, if you take a look at your podcast feed and you're missing episode 10 and 12, that's because those episodes are exclusive to members of Nexus Pro. Sign up for a Pro membership to get your personal podcast feed with access to all of the episodes. Without further ado, please enjoy Nexus Podcast episode 13. So, hello, Deep. Welcome to the Nexus podcast. Can you go ahead and introduce yourself?
Thanks for having me over, James. Yeah, so I'm Deep. I'm the CEO of 75F.
All right, and what is 75F for those that don't know?
Yeah, really speaking, we think of ourselves as building automation in a box, right? So what we've done is instead of trying to go and attack a very small layer in terms of putting in a software layer or just making smarter sensors, we decided to actually do the whole stack. So we have our own sensors, we have our own controllers, we make our own gateway and aggregation units, and on top of it, we put our own software, which is both in the building as well as in the cloud. So that includes things like remote access and portals, but also the machine learning stacks that we've created. So all of that is really part of 75F. So it's a complete building intelligence solution is how we call it. We don't just call it building automation, but we make it simple enough that it works out of the box. So it really doesn't require a huge amount of system integration. Actually requires zero amount of system integration.
Cool. Yeah, I'm super excited to dig into a lot of this. I've been waiting to interview you for a while. So why don't we start with like the founding story of the company? So, I mean, I've talked a lot about how I think the building automation industry is broken. So I don't want to throw that story out there. I want you to tell me how it actually came about. So how was it born?
Yeah. So it's an interesting thing. So I'm not at all from this industry, right? I'm a computer geek, mostly a network dude. So if you use Verizon as an example, there's a 95% chance it goes over a backhaul that I did. I had one of the world's first terabit routers sitting in my garage for 5 years. But when my daughter was 1, we just moved her into her own bedroom. And she would wake up in the middle of the night crying. I was trying to figure out what's going on. And we found out it's because the temperature in her room was dropping about 10 degrees at night. Right? So she would be very extremely uncomfortable and get up. So as a self-respecting engineer, I wanted to fix the problem. So I quit my job. And here we are, we're chatting.
Okay. Well, fill in some more of those details. So, how did you go from, say, fixing the air in your house to the commercial buildings industry, and what
Right.
made you feel like the controls market in this industry was an opportunity for a startup?
I mean, I really started to fix my own personal problems. So when we originally started, we were really looking at the company called Keenvent and EcoHome. They started making this way after us, but I started a company called Santulit, which really made these motorized dampers that you could put into each room in a house to turn on and off the airflow in there, right? So it's kind of primitive zoning, but it's at the terminal side. What it's doing is instead of going and putting a damper in the ductwork, you're really using the resistor to control it automatically. And as we progressed through that, we actually went to a pretty late stage. We were in talks with GE to produce it and Best Buy to distribute the stuff. We found that there was basically about 25 different SKUs, the units that you sell, that we would have to create because the registers come in so many different sizes in the residences in the US, right? And because of that, I mean, it was from a logistical perspective, very expensive proposition. So we abandoned that piece because it required too much shelf space. But the idea, as part of that journey, I mean, I found that if it was an issue in residences, it was a bigger issue in commercial buildings. And I was a little bit surprised by that. I mean, with due reverence to Johnson Controls, I go into the headquarters, they have the steam-powered zone control systems going back 150 years, right? But the industry really hasn't progressed that much in the last couple of decades, right? Even what we see now, the DDC controllers and the BACnet pieces really came in the mid-90s. So we haven't really caught on to the true IoT revolution. A lot of companies are claiming they're IoT, but IoT is more than just saying that we're connected to the internet, right? IoT is really about being current, being over-the-air upgrades, and just taking this connectivity ubiquitously as granted, which is not necessarily the case in the industry, right? So when I came in from the telecom side, I was a little bit surprised that this is an industry which, I mean, controls a large amount of energy. I mean, the fourth largest emitter of GHG gases is our buildings, right? And all of a sudden, we have technology which is very outdated. And I primarily think it's because most of the folks come from the mechanical side and not necessarily from the IT side. So most of the standards are not necessarily have caught up with the same pace that we've seen in consumer electronics as an example. So for me, this was an opportunity. The commercial buildings presented more standardization. The dampers are more accessible. You have, right, the more commonly configured sizes. You don't have to stock them. They're also available more easily. So we actually shut down the old company, Santolet, and I recreated this new company, 75F, specifically focused on commercial buildings.
Right. Got it. And what year was that 75F started?
2012 is when we started. And I was primarily originally focused on the light commercial buildings. So I was thinking of the same thing. Residential, now let's go into smaller buildings under 10,000 square feet. People can buy a solution from a distributor. And essentially, once you've got that, they can go put it in themselves. So that was the whole genesis, that let's keep it relatively simple for smaller buildings. Things have evolved over the last few years, though, right? I mean, it's interesting. I mean, you start seeing these cracks in what's out there, and you keep wondering like why it's not been addressed. And I do believe that the business cases, I think you've discussed about it as well, that it's a question of how are people incentivized to make money, right? How the channel has grown over the years, right? So there's a technical issue, but there's also a business issue as well.
Big time.
Right. And if you're not from the industry, then you're not encumbered by either. You don't have to support legacy customers, and you're not necessarily beholden to say that, hey, we have to serve the same channel that is going to market. So your go-to-market could be a little bit different. And I think we brought that fresh approach, being outsiders and not necessarily knowing what we were doing.
Yeah, totally. Cool. So I want to just hit on a couple of these. I mean, you've mentioned a lot of these differentiators already. So maybe just take us through like why you decided to create a full stack. So you recognize this is an issue, but you're actually creating sensors, controller right. Software, cloud software, the whole gamut. So why'd you decide to do that?
The primary reason is like, I look at the controls industry as kind of like the computing industry back in the 70s, right? Back then when you bought an Apple I, you brought it home, you soldered it together, and then you learn programming in BASIC to solve your own problems, right? And today, it's inconceivable to not walk into a mall and you want to buy an iPhone in 3 minutes. Of course, you can't walk into a mall these days without wearing a face mask, but that's if you can,
whole separate story.
So this is a different story, right? But if it ever takes you 5 minutes, you're probably screaming bloody murder. It's like, this thing is bad, right? But it's kind of weird in the controls industry. We still accept that system integration and taking a product from Schneider and then taking another sensor from ACI and then tying them together through custom code is acceptable. Right. And that to me is kind of weird. It's part of it. Yes, standards exist for interoperability, but they also make it harder that nothing works out of the box, right? And if you look at it, I mean, the standards, I believe, don't necessarily need to exist at a device level. Really, if you want to have these days, I mean, the system should work out of the box. I mean, you don't really care what standard your iPhone camera uses to communicate with the rest of the processor. What you do care is about the base level functionality and like how does it interact? Like, is the file system which is supported, is the photo a JPEG or a PNG which can be exported out of the unit, right? So if we accept that kind of modularity, I mean, if we accept that that is a black box, then that really allows us things to be more efficient. Not everything needs to be interoperable at every stage is how I look at it.
Okay.
Right. So our take was that, all right, let's make sure that instead of saying that the humidity sensor itself needs to talk BACnet and go right to a controller, let's make sure that the humidity sensor and the temperature sensor and the volatile organic compounds and the CO2 sensors, let's not even make them optional, right? Let's put in all of these sensors out of the box, and because the hardware has grown, in all honesty, to be super reliable and cheap, right? We end up using the same sensors. When I started originally on the residential side, I mean, we used the Fluke temperature sensors were about $350 to get a reference quality Fluke sensor. We have the same sensor in every one of our rooms now.
Wow.
Right? So overall, if you look at just how, and it's part of the mobile revolution, right? I'm not taking credit for it. What I'm saying is that, I mean, the consumer electronics have really driven, the mobile revolution has driven such good standards in terms of sensors and overall technology that what we really need to do is keep pace and take advantage of that. And that's what we're doing. We're packing all of these sensors, packing in all of this functionality out of the box, right? And the second piece that we wanted to do is we wanted to have that instead of having a dedicated application-specific controller, that you have one controller that takes on different personalities depending on what equipment you connect it to. So it's kind of like your iPhone is one box. It's got all the sensors, got all that functionality baked in. Depending on what app you're using, you end up having a different profile, right?
Totally.
So,
yeah.
Because the value is in not necessarily going and integrating and putting these things in one at a time. So it's not unique in terms of what the industry is doing in the consumer side, right? We accept this in our phones, we accept this in our cars. We've just not somehow got it in our HVAC and our buildings yet, right?
Totally.
We look at the totally integrated scenario. Nobody talks about is like, hey, is my car talking BACnet to the next car?
I agree. Yeah. So it sounds like also one of the benefits of it being full stack is it's also super easy to install. All right. I mean, like you kind of hinted at that with the iPhone example, but it can be very quick, right? And I think that's one of the things you guys were going for initially too, right?
Right. You're spot on with that, right? I mean, that was the whole idea that we wanted to make it very easy. But back to my roots, I was really thinking that like, why did this control solution in our home not work? And it's primarily because we made it overcomplicated. We've got all these pieces to tinker around. We're not looking at it as a solution. We're really looking at it small pieces that needed to be brought together. So we had this paradigm. We did a project in an elementary school, and we asked the kids who were 8 and 9 years old to go put in our system ourselves. Right. So the idea is that, so we always have this thing. I mean, our system's gone, in all honesty, a little bit more complex now. We're doing much larger buildings. We're doing 1 million square feet sometimes, right? But so maybe the same students could do it now, right? A little bit older, 10 and 12-year-old kids could do it now. But at that point, it was revolutionary that you could go put in a control solution that the kids who had no training at all could go put it in. Mm-hmm. And we've kind of kept it as part of what we look at when we add features is like, does it increase the complexity and the debt in terms of cognitive burden on the person who's installing it, right? Because you can give all of these options, but the more options you add, the harder it becomes to actually use. Right? So like your grandmother, is pretty hard for them to pick up an iPhone these days and use it out of the box, right? It works out of the box, but if you ever went to settings and try to configure a thing, I think it's a little bit more complex than the initial system, right?
Yeah.
So we've been pretty mindful about that. Is like, how do you hide all of that complexity and make it so that the machines can do that, right? So I think we were talking about Descript, right? All the things that you can do with Descript. I mean, that's absolutely amazing. To try to do that by hand would be nuts, right? And yet that compute power is available. It's abundantly available, and all you got to do is harness it.
Right.
Yeah,
Cool.
So that's what we did. Is like, let's harness the technology curve very aggressively, because the way I look at it is like purely from an energy efficiency perspective in terms of the CO2 emissions. If you look at where we are not, our CO2 levels and the GHG is not rising linearly, it's rising exponentially, right? And so the only thing that I know of that we can actually use, the only other thing to counteract that is Moore's law, right? Like, our compute power is the only other thing which is non-linear that I know of in terms of technology. So we got to be very, very aggressive in making sure that we are always keeping ahead and keeping track where technology is, right? And making sure that we have very aggressive price points for compute.
Totally. So since we just talked about plug and play, I also wanted to talk about small buildings. And so it sounds like you started with small buildings, and now you're progressing into, bigger and bigger buildings as the company expands. But can you talk a little bit about the opportunity with small buildings? I mean, I don't know a whole lot about it. I spent most of my career with, big buildings and campuses. But the way I understand it is like there's a huge opportunity for automation in smaller commercial buildings, medium-sized commercial buildings across the country, across the world. So what are you guys seeing there?
You're right. I mean, 90% of the buildings are under 200,000 square feet, right? So there's a relatively large number of buildings in that stock. We have traditionally looked at the buildings which are obviously much smaller, right? Because we can go in as a retrofit, we are much easier to put in. And what we're trying to do is make it more accessible so that people who didn't think that they had a cost-effective solution, and out of those buildings, I mean, most of them don't have BMSs, and the primary reason is because they're too complex and too expensive, right? So we were really looking at these smaller buildings and saying that's the sweet spot that we really want to address. What we did find is that buildings under 10,000 square feet, which I thought would be the primary market to begin with, right? Those folks are not as concerned about actually having temperature control or about energy because the numbers are too small, right? So the sweet spot, I think, is really somewhere between 20,000 square feet to about 250,000 square feet, beyond which I think controls are kind of accepted, irrespective, right? But the sweet spot is really, can you go address that? And that's kind of an very important segment for us, specifically now, given where we are with the COVID situation, right? And where the CDC and ASHRAE guidelines are, right? So we are going back to a lot of not only our customers, but new customers, churches, schools, right? Business manufacturing facilities, which are specifically working 24/7, as an example, right? Light manufacturing. So we're going back to them and making sure that their workplaces are safer, given where we are. So specifically, we introduced something called epidemic mode, which implements the CDC and ASHRAE guidelines. Right. So that's a very important segment, spot on.
Totally. And it sounds like, before they might not have any automation at all, and you're going in and saying basically, hey, this is an opportunity to start controlling, measuring your ventilation, right? And making sure that you have enough. Cool. So before we get into epidemic mode, I do want to hit that next, but I think your platform enables epidemic mode because you're able to push sequence updates to controllers. And I think that's a huge differentiator, compared to the old way to do controls. So can you talk a little bit about why you did that and how that works?
Again, I do believe in the future, this is what we will see, right? I mean, we take it for granted that your phone is going to keep updating.
Yeah.
Right. And now you have the cars which keep updating.
Right.
So why not your HVAC system? right? And so even day one, I mean, that's what we started with over-the-air firmware upgrades, and also our central control unit, which actually runs the algorithms holistically for the building. So that keeps updating regularly. And in fact, it keeps updating both from the sequence of operations, but also on a daily basis, it actually gets updated in terms of the tuners, because we create a ML model. So we look at the weather and we look at the past history, and we figure out what's going to be the optimum tune points, set points for making the building work, right? And these are not just temperature. We don't change temperature set points, because I think that's kind of, I have another beef with this, right? I don't understand. I think it's a kludge to try to change set points to get your controllers to do something different.
Totally.
Right. And it's primarily because I think that the controllers are locked in terms of the sequences that they have. So the only option normally available is like, how do you fool them into doing something different?
Mm-hmm.
And that's really hard science, in my opinion. Like, not a hats off to companies who are trying to fix that, because every manufacturer, every deployment has a different understanding of what the controller should be doing anyway.
Right.
Right. So now you have lots of different variances that you really have to account for in your ML models, which is why I don't think machine learning and tweaking has truly taken off, because every building is an exception, right? And ML only works if you can tune the model and if you can train the model, right? So we decided that we want to standardize this. So the idea is that out of the box, I mean, we use like true software processes and test harnesses to make sure that it's not just the software which is working, but the sequence of operations are doing what they should, right? So unless you've regression tested this, the point of like continuous commissioning is, to me, so weird, right? Because I mean, that should be a given. The fact that we have to go back and recommission buildings makes no sense at all. Right. It should work out of the box, and this stuff should self-tune. I mean, that's the whole point. If we look at our apps, if we look at where the world is with, like, we actually have continuous integration and continuous deployment things, right? In terms of microservices and how we update the web, as an example, right? And none of those things have somehow carried over to this domain, right? But from my perspective, where I came from, I mean, that was a given. That things work, they always keep changing, and you push them out as sequences get better, technology gets, our understanding gets better, you keep on pushing these updates out. And that's what we really did over the air upgrades, as I said, not just for our central unit, which is running Android, the gateway, but even for each of the edge devices themselves.
Mm-hmm. Okay. So just so I'm learning here too, so if you think about like a machine learning product that is tweaking set points, how does your machine learning work differently than that?
Right. The biggest difference is our machine learning is really looking at loads in the building. Okay. Right? So it doesn't have to keep changing set points. What it does is we have a concept of what we call tuners. Tuners are things which can affect the functioning of an algorithm. As an example, we have a bias towards saying that, hey, if you already have an ML model and you know that it's going to be sunny, then your load in the building is going to shift more, right? And it already knows that from the weather forecast model, but it doesn't actually. So it's really saying that the load is shifting. By 2 p.m., the load is going to be 30% more in this part of the building. What it doesn't have to do is, like, the set points don't have to be changed, because that's really a hint to the system that you're going to start putting more air before the set points have to be tweaked. Right. The problem is that everyone's using proportional integral systems, right? And because you're using PI controls, what you're doing is you're trying to use the delta T in between the set point and the current temperature to try to fool the system to get it to do something else. Whereas the true problem is really that you've got an increased load coming down. You should really be conditioning beforehand. There's no reason that you really need to be trying to tell the PI loop and fool it to do anything different, right? So I look at the PI loops and stuff. Those are really for more reactive, for course correction in tweaking. But if you already know that the load is going to be more in a part of the building, let's just open up the dampers predictively, proactively, right? If it's going to be a cloudy day, then you really know that the load is going to be more uniform. It's occluded, so that there's not going to be as much directionality to the load. So that's one piece, right? You can use things like, even things like, when do you turn on for preconditioning, right? I mean, you already know that based on what the current temperatures are and where the outside temperatures are. And so you know what your cooling rate or your heating rate should be. And you know the delta T in the temperature and set points. So don't change the set point. Let's just figure out the right way of doing it.
Right. Yeah. And I've talked about in the last couple essays I've written about this. There's like, I think everyone that at least reads Nexus is like, okay, we agree that the existing BAS paradigm is broken, right? Okay. Now there's two solutions to that, in my opinion. There's the overlay, which I think we're describing the overlay. And then there's the throw it out the window, build it from scratch approach, which I put you guys in that throw it out the window, build it from scratch approach. And I think what we're highlighting here is like two major differences. So I just want to kind of restate it to you because I'm learning this out loud. But the overlay approach would say, okay, I have all these PID loops that are operating based off of set points. And the only thing I can do in my overlay is just start overriding set points, right? Whereas what you're saying is, no, actually we can, if we're building it from scratch, we can actually just take that PID loop sort of not totally out of the equation, but we can start operating the system directly, essentially.
Correct.
Yeah. Okay.
And you're spot on, right? And you do it holistically. I mean, that's the biggest difference that I look at is the current BAS systems are the tail wagging the dog, right? It's like your PI loop is typically running in your room, and it's really controlling the VAV damper opening, as an example, right? So your communication back to your actual BAS is typically by duct static pressure. Right? Yeah. No one is actually saying what should be happening in all the zones which are being served by an AHU. You've not figured out what the total load is. You don't know which part of the building really requires a load. All you're doing is you're using duct static pressure as some kind of a mechanism of figuring out, yes, there is more required load in some part, right? I think the closest we've come to is now with GPC 36, the ASHRAE standard, right? Advanced Sequences for HVAC Operations. I mean, what they started doing is sending some feedback back in terms of trim and reset, trim and respond. And that's a mechanism that is, in some ways, a coarse PI loop mechanism. The requests are the equivalent of showing some load in the terminal units. Right. But, I mean, there are far more interactive, far more real-time systems available that we've implemented. We also implement GPC 36, by the way. Right, because some engineers really want the assurance that is a very well-defined mechanism, which is well-known. And so we implement GPC 36, and we've committed to the fact that as GPC 36 evolves, we will keep updating our sequences. And more importantly, I mean, we do reference quality GPC 36. So it's like using software techniques, crew test harness stuff, which does regression and all. And so we run it through the whole shebang. So you don't really have to commission it. It works out of the box. Totally right. But the key is that, I mean, from our perspective, GPC 36 is the lowest level of, I think, current control solutions that I would actually consider acceptable. Right.
Well, I mean, let's just pause on GPC 36 real quick. So ASHRAE is coming out with these new sequences, and ASHRAE is saying these are the top sequences, right? So in the old controls paradigm, I just want to kind of lay this out for people that are new to this topic. The old control paradigm is that every single building that's been programmed in the past, right, now someone has to physically go there and say, okay, let's upgrade these new control sequences and basically program them by hand. And what you guys are saying is, no, I mean, every building that's ever had 75F installed on it now can get these control sequences automatically. Just like the Tesla that everybody wants, right? It's getting control sequences essentially automatically pushed to them. So it's just like this huge upgrade for the whole industry if all controls companies did it like that. Cool. All right. So one of those newer sequences, right, is what you guys have kind of used to respond to the pandemic, which is epidemic mode. So first, I want to kind of get your take as a leader in our industry, kind of where you see the industry being at right now. So it's middle of July 2020. Someone's listening to this 5 years from now, but we're kind of still in the middle of this pandemic. There could be a second wave. It certainly seems like there's a second wave coming. So how are you feeling about the state of the buildings industry and the smart buildings industry specifically?
It's a loaded question. I think there's going to be some winners and losers, right? I think the existing building stock is not going to be utilized the way it was before. I think this change that we are seeing of working from home, at least partially, is irreversible. We've kind of accepted it. So the two things which are going to be I'd look at is like building owners, and we've talked to a bunch of them, right? Real estate folks should be really worried, and they are, right? Because I don't think the tenants at this point, we're laying it down to the second wave, but it's not just the second wave. I think this is going to be a long-term proposition. The same thing with air travel, right? We're doing it now as an immediate reaction, but I think even long-term, the acceptance of digital communication is just going to be so much higher. I don't believe that we're going to go back to that same way anytime soon. Definitely not in the 5 years that we were talking about, perhaps.
Yeah. Okay.
Right. But so if that's the case, I mean, what you really want to do is like figure out like how do you make buildings safer, right? I also think this is an opportunity to make buildings more adaptable, because this is just one thing. So the buildings that, as an example, that have the 75F system, I mean, it's seamless for them to get these updates.
Right.
Right. But it's not just us. I look at it as like, if you want to change, use the right technology so that you can keep on harnessing change, right? That you can be adaptable, whether it's epidemic mode now or it's a better energy saving sequences later on. So what we are doing is we're going back to a lot of these buildings we're talking about, the 20,000 square feet to 200,000 square feet, and saying, hey, folks, like how can we actually help you make your buildings adaptable? How can we make them more healthier now? Right. And at some point when we have a vaccine and things go back to normal and more people are coming back, can you actually go back and start using modes which are more energy efficient? Right. Because there is obviously a cost associated with any of these modes that we're talking about, which are talking about enhanced ventilation as an example, to dilute the load, the viral load in a building. Right. And the flip side of which is, I think we're going to come out of this and people are going to say that it's not just the viral load, but it's also there's going to be enhanced awareness in terms of the indoor air quality in general, right? We've been talking about it for a number of years, but I don't think we have actually truly taken steps towards that. So now we can come back and it's like there's going to be more, just an overall awareness is going to be much higher in terms of IAQ and healthier buildings and being more adaptable and intelligent. And that's one part of the message that the building owners that we're talking to understand that. Like they want to say that, hey, our building stock is the healthier one, is what they call it a clean asset is how they look at it. It used to be the clean asset term was used primarily from an energy efficiency perspective, but now you're looking at it from a well-being as a healthy building standard, right?
Okay, cool. Yeah, totally. So let's nerd out on epidemic mode real quick. So I've been putting in the newsletter each week. I've been kind of saying like, here's the best articles I've seen on the pandemic, so far. Here's some good ones that if people are looking to keep up with it. And what I haven't seen really at all, and I've been saying this, is like everyone's talking about more ventilation. No one's talking about the impact on the energy consumption. And I watched your webcast from last week, so I learned a lot about it. But I want to hear like where you guys are coming from in terms of this epidemic mode. And again, it sounds like it's a control sequence that you're able to push out and let operators decide whether they want to turn it on or turn it off. But what does it actually do, and what are the benefits of it?
Right. So back to where the CDC and ASHRAE guidelines are, what they're recommending right now is that you run your systems 24/7 and you run them with increased amounts of outside air, right?
Which, as an energy engineer, I've been undoing that for my entire career, right? So it's just like, wait, we've been undoing that for so long.
I know. It's like, let's put them on schedule, so right? So, and there are reasons behind that. And the primary, we've talked with some of the folks on the task force, right, both in ASHRAE and on the CDC side. And the primary reason for that is that in some ways, if you think of a current building out a BAS system, you only have a concept of occupied or unoccupied. There is no concept of saying, hey, let's have a pre-purge, a post-purge, or all right, let's have a epidemic mode sequence right in there, right? So there is no state called epidemic over there. So in terms of safety, what they've had to do is they've had to bring down the standards to the lowest common denominator.
Got it.
And it is kind of an interesting thing. You go back, this thing is more rampant than just these current CDC guidelines. It's actually rampant in everything we do. It's rampant in ASHRAE 62.1, which is the IAQ piece, right? It's rampant in even GPC 36. If you look at GPC 36, the original predecessor to that RP 1455, when they were looking at it, they were looking at not just the best control sequences, they were looking at the best control sequences that could be implemented in an existing controller and with people who were at the level of like a master system integrator, not at a rocket scientist kind of level, right? They were trying to figure out like what can we push out which can actually practically get consumed.
Got it.
Right.
Makes perfect sense. I never thought about it like that before.
And those are the constraints of the folks who are making these recommendations, because they have to go back and make sure that they apply to everyone. Because if they put in an advanced sequence that people can't comply with, then like, what do you do with that building? Do you throw it out? Do you shut down the building? Mm-hmm. Right. So they've actually tried to simplify it, dumb it down, and said, hey, run the system 24/7, run it at enhanced ventilation, right? As much 100% outside air if possible, if not, as much as you can, right? Because there's no epidemic mode, because the system was not rated to run 100% all the time, what you have to do is now figure out what is it, the amount of outside air it can do under extreme design days, right? Mm-hmm. Most of the days it perhaps has capacity, but on some days, if you try to get in that enhanced ventilation, the system cannot keep up, right? Because it's not adaptable. So that's kind of where the recommendations were. And so that's the baseline that we took. So it's interesting. We were actually doing a project with NREL as part of the IN2 program, right? So the Innovation Network 2 program. And they were specifically looking at the energy impact and savings of 75F across multiple climate zones and different building types, right? So when the pandemic came around, we looked at the literature, and there was absolutely zero literature talking about what's going to be the potential impact of these recommendations that the CDC and ASHRAE are putting out. Mm-hmm. So we actually talked to NREL at that point. So Grant and gang who are leading that project over there, and decided, hey, let's divert some of the resources that we're going to look at normal operation and use them specifically for this epidemic mode. Right? So we had a theory. The two things that we wanted to test out is, A, from our perspective, you don't need that ventilation all the time. You really only need it when the building is occupied. Second, the other thing was that the reason though the CDC said you want to run it 24/7 is because the concept of a purge means that you cleanse the building with a high amount of outside air for a short duration. And the ASHRAE sequences at some points talk about the purge, pre-purge, and the post-purge as well, right? But the CDC did not, because they really had to bring it down to the lowest level. So we actually tested these out, and we did some pretty interesting experiments. Obviously, no one's detecting the COVID virus itself. But what we did is we did some experiments in which we used, since we've already got volatile organic compound sensors built into the product, we actually use paint and alcohol as the two substitutes. And we use cotton balls dipped in alcohol. And when you took it out, we figured out how long it would take for those cotton balls, the VOC levels, to decline.
Okay.
All right. So in normal mode, in a normal AHU operating normally, and the average hertz was about 50% of capacity, it took about 2 hours for the VOC levels to decline to baseline. When you raise that up to about 60%, 65%, it took about 1 hour. Now, when you raised it over to 80%, it only took 12 minutes.
Oh, wow. Okay.
And the primary reason is because the airflow starts becoming turbulent, right? So your actual ability to extract and entrain the air and extract it is far more efficient, right? Which is what, in my opinion, like, no one's done these studies before, but we wanted to test it out as like, yes, so if you truly wanted to do this, what you want to do is you want to run the fan at high speed. You want to get a whole lot of outside air for a shorter period of time and get it all cleansed.
Totally.
Right? So that's what we did. We introduced this concept of a pre-purge and a post-purge. So it's prior to occupancy and after occupancy. And back to your point, you can turn them on and off as simple as just a slider on a phone. And the system automatically does that. But while you're doing these purges, at that point, you really don't want that the set points should be maintained. So it's not the same as saying, hey, let's move my schedule earlier. Because if you try to maintain set points, then you have a very tight temperature dead band. You're getting in a whole lot of outside air. And you're really going to be consuming a huge amount of energy to make that happen. Right? So what we said is it's going to be in setback. Right? So it's going to be the temperature bands are going to be way more relaxed. You get in this air, all you're doing is diluting the air inside and purging it out. And then when the purge is complete, then you tighten the temperatures back to set point, and you also reduce the amount of outside air that you're getting so the system can maintain those temperatures. Right?
Got it. Okay.
So
what about during occupied mode?
So that's the occupied. So during occupied mode, you bring down, you still get enhanced ventilation, but not 100%.
Got it.
Right. Okay. And that enhanced ventilation in our case is tunable. It's again using ML, but we normally set it as a 50% as a baseline is what we set. Right. So back to that energy impact study with NREL. So that's the mode that we implemented, and we asked NREL to actually go back and do this validation. And the results are eye-opening, I think, in terms of the energy impact, as you might imagine. Right. And that just following the CDC guidelines is going to be somewhere between 3 to 5 times in some cases, in some climate zones, 3 to 5x of what your baseline energy is.
Right. And is that total building energy or just HVAC energy?
Just the HVAC piece. Yeah.
Yeah. Right. Okay.
Yeah. Right.
So they basically ran the way I understand it, 3 open studio models, one with normal operation, one with CDC guidelines, and then one with epidemic mode. And what were the average savings for the epidemic mode from the CDC?
Right. We actually ran it in 4. So we ran it in normal mode, we ran it in CDC guidelines, and then we ran it in epidemic mode. And we also have within epidemic, remember that we have occupancy sensors.
Right.
Right. So we have a concept that, which is something that we're seeing that many of our customers are not getting in all the teams, all the employees in on the same day. So if you have staggered days of occupancy, using the occupancy sensors, it saves a fair amount of energy as well, because you're only trying to condition those parts of the building which are going to be occupied. So when they ran that, what we found is that the CDC, on average, the CDC guidelines end up about 3x to 2.5 to 3x over the baseline energy usage for the HVAC. The epidemic mode in an office scenario was about 30% over the normal mode, right? Which is about 50% savings over the CDC guidelines, which is like significant since now the top line is so large. And if we actually use the epidemic mode with the staggered occupancy, we were only about 15% higher than the baseline, which is like exceptionally nominal. So back to your point, the point I was making is that if your buildings are adaptable, now you can make them healthy without necessarily incurring a huge cost as well.
Totally. And what are your customers saying about epidemic mode? What are you hearing from them? What kind of problems is it solving for them?
It's solving some problems. It's also highlighting some problems, which I had not anticipated, by the way.
So, oh, really? Okay.
Right. So it's solving the problem that obviously we give this nice decal as a sticker, because one of the key things is many of the things that we're doing, we don't know everything about COVID-19, right, or the coronavirus. Mm-hmm. What people are looking for is visible. They're looking for visible signs that you care, right? So one part of it is like we made these large decals, which let people know that the air in this building is being purged, right? So from a confidence perspective, I think it's been absolutely fantastic for employees and customers, and especially some of our retail customers have adopted this. And when their people come in to buy into that store, they now know that the building is safer, right? So they've actually seen it's a big differentiator. Back to the point of like, even from a marketing perspective, like which store would you want to go to?
Totally.
The healthy store or the not so healthy store?
Yeah.
Right. So they've seen those kind of responses. The things that we found out that we didn't necessarily expect is that we keep talking about how bad people maintain equipment sometimes. Mm-hmm. Right. We found out, I mean, the economizers obviously are notorious, and we had obviously tracked this in terms of like, is the economizing working or not based on mixed air temperatures with our piece. What we found was pressure problems. We hadn't done as much economizing at such scale
Right.
all the time, right? So a huge amount of positive and negative pressure differences started popping up in many places where you ran all the systems at 100% outside air, as an example, during purge cycles.
Got it. Yeah.
Right. So, and it's an interesting thing. I mean, we keep thinking that for the first time you start recognizing why you need variable capacity fans on the return side as well.
Absolutely. That's something to watch out for. And this is where all of our commissioning agents, shout out to all of them. This is where we don't really need them to be tuning sequences, but we do need them to go figure out these issues that are popping up.
That's true. Yeah.
Cool. So there's a couple other issues I think that I'm seeing as you start to increase ventilation. It seems like there's going to start to be, and you touch on this a little bit, but equipment capacity issues, right? So if someone's out there just opening ventilation dampers 100%, not just pressure, but also like chillers can't keep up, chilled water coils can't keep up. Once we get around into the winter, there's going to be a lot of preheat coils that can't keep up, those types of things. So I feel like these dynamic sequences can help find that edge, right, a lot better. And then with humidity, so we're in the middle of July in the United States, maybe not in Minnesota where you're at, but well, it actually gets pretty humid there in the summer. But managing humidity as well, I feel like is super important, right?
Right. And that's something that got highlighted in the simulations that came out from NREL as well. So looked at two other aspects in addition to the energy piece, is like how well is the temperature being regulated. And that's I think back to your point that like we actually had to turn down the amount of outside air which is coming in terms of the CDC models because they're running 24/7, right? And it gets really, really cold in some of those places. So like extreme Minnesota winter was a pretty decent example where the building temperatures were dropping and the system was not able to keep up. Right. So that's something definitely worth keeping in mind, and ditto with humidity as well, specifically with the outside air coming in consistently. It just in Houston 2A was like during a design day, the humidity was almost 70% inside the building, which is getting out there.
Yeah, definitely. Okay. Well, cool. I mean, I'm super excited. I was pumped up watching the webcast about this, so I'm excited to see where that goes. And I hope people start copying off you, frankly, because I think this is a needed upgrade to control sequences.
I think that's a good point, James. I mean, when we did this, even when we talked with NREL, yes, we had our funding, but that's why we wanted to share it with everyone, is that these are the results and these are the sequences. So we are actually super crystal clear. So even if anyone else is ever looking for like our sequence of operations, what we've implemented, by all means, I mean, we're making these public. I think if medical vaccine makers can collaborate, I think HVAC companies can collaborate as well.
Exactly. I love it.
Yeah.
So let's kind of pivot back to the product itself. So you know, I have talked a couple times, so I feel like I understand the product pretty well. But let's kind of start with software. You guys again had the chance to just throw the existing automation, front end paradigm just totally out the window. So how have you what makes a good software layer, and how have you guys approached creating that in the product?
I'm glad you're talking about it now than maybe 2 years earlier. Right?
Okay.
Because our understanding has evolved as well, right? So when we started, we were really looking at as a product, right? But about 2 years ago, as we decided that we're going to go scale the technology up, we actually made it so that it is exceptionally modular and a true platform, right? So we actually, one of the key things that we did is, it's kind of weird. I keep dissing standards like BACnet, but on the other hand, I'm really gung-ho on places like Haystack. And I know you were talking in the last episode on BACnet 2 to 3, right? ASHRAE 2 to 3 and Haystack. So we made everything within our product layer now in the software stack as 100% Haystack compliant. So all our apps, all our portals are actually running reference implementations of Haystack apps. We end up using the same API that we would actually expose to our customers, right? So I'm a big fan of interoperability, but as I said, not necessarily at a lower layer level, but at the right scale. And to me, I think Haystack is probably the first place where we've actually started getting some standardization around that piece, right? So And especially when Haystack 4 gets completely flushed out, or whatever ASHRAE comes out with on the 2 to 3 committee, I think that's going to be exceptionally important. So when we designed it, we made it super modular now. And so it's completely, originally it was just cloud hosted, but now we call it completely, because some of our customers want it hosted in their own private data centers. And we have some countries which have restrictions in terms of that the data should be stored locally. So we call it a hybrid public-private cloud. So it's completely containerized and Dockerized. So you can actually deploy it with what's called CI/CD, continuous integration, continuous deployment. So it is as good an architecture from a software perspective as can be, right? And that's because we decided to re-architect it, as I said recently. And now it's to the point that, I mean, we really look at like how our smart city is going to scale on a platform like this, because we have some partnership, as an example, with Singapore Power. They're the world's largest district cooling utility. But what they're doing is they're going and replicating their entire package of how to do district cooling to other countries and other districts, not just Singapore, right? So they're selling it as a service, and so we are the technology stack on the building automation side for that, right? So whenever there's a new smart city or a smart district which is going to use Singapore Power, they're all going to be using 75F technology. So we decided to go back and make sure that the technology would scale to those levels, because as we go in the future, I mean, the whole concept with this distributed energy resources, as solar and wind become more prevalent, it's no longer going to be the case that the grid is going to scale up to the load. The load is going to have to adapt to the grid, right?
Yep.
So if that's the case, we really need bidirectional data models which allow massively parallel compute in terms of machine learning, etc. And so that was the whole genesis behind making sure that we had a semantic model in addition to just storing the data, right? So Haystack really fulfilled that.
Totally. And anyone who's listened to the last episode knows that this is a different perspective for someone that's in the building automation world to design their product with Haystack natively, basically, is what I'm hearing. So why did you do that when you're a controls company, and why do other controls companies not build like that?
It's like their legacy, right? I mean, if you already have a database, I guess you don't really care. But I mean, to me, it makes a lot of sense. I know you come from the energy auditing piece as well, right? So you probably use SkySpark, but it's kind of weird to actually connect SkySpark to a building which has BACnet and then manually map all the data over, right? And I mean, it is a huge amount of work, and it's like, it boggles me, it befuddles me why others won't do it natively, but I can only think it's because of legacy. That's how it's always been done, right? But we decided to do it natively out of the box. So everything, even our algorithms, when we did RP55, GPC36, it's kind of weird. We don't even look at current temperature. We look at points. So we actually make a call to say the Haystack tags, which would actually allow you to say point his current zone, right? So it's really a call every time we use. There's no variable names in all of our algorithms. So we are like hardcore into this
truly
stuff.
Native Haystack. That's amazing.
Truly native Haystack. I mean, if you look at our analytics, our widgets which go and display all of the data, every one of them is a true Haystack call.
Wow. Yeah, I'm sure Brian Frank and the guys that started that are pumped about that. So cool. So a couple of different questions about the software. First is, you mentioned SkySpark, for instance. Are you guys in your front end, I guess, to use an analogous term to a traditional building automation system, are you guys adding in analytical capabilities like fault detection, diagnostics, and that type of thing? And how are you thinking about that?
Absolutely. So, I mean, all the analytics are built in. The slight difference, I think, versus SkySpark is that SkySpark allows those rules to be set, or sparks, which get right, and they're highly customizable. We've tried to do that out of the box, right? I think we have the luxury in our case that we already know what those FDD pieces are going to be. So like with GPC 36, of course, they have their own concept of what the FDD should be, and that's already built into that product. And what's kind of cool is that every one of, again, I go giddy over this, so kudos to Brian, as you said, and gang. But I mean, even all our analytics and FDDs are all making Haystack calls. right? So it becomes, that allows you to scale, right? That allows you to specifically, if you have equipment which is being replicated, right? You don't have to do that for each and every point. Now you just have to do it for the tags that match that value. And I mean, that to me is the true value. Like if you go shoe shopping, or if you go to Best Buy, we use tags all the time, right? You go search for TV, then you go search for 40 to 50 inch. You're searching for a price point between $400 to $700. And if you look at if you go to their site, that's what they do. They really put those tags right at the top as a filtering mechanism.
Mm-hmm.
Right.
Yeah.
And that to me is the beauty of what Haystack has really done. And we really took it to heart as like, go all the way in and make sure that every algorithm, every FDD, even our customized code sequences, we call it IFTT, like if this, then that logic uses the same concept. It's like, if these tags are this value, then do this command.
Got it. So how do you guys deal with, you mentioned sort of waiting on Haystack 4. How do you guys deal with the sort of limitations to the data model as it exists today?
Yeah, I think we've made our own customized extensions for the time being, right? I think the primary shortcoming that we found was that in the reference model, that it always goes and references one site or one equip, and it's not bidirectional. So those are some of the limitations that we have in Haystack 3. So we added more references, which are 75F custom, not just the tags, but more references to like floor or a zone, which are constructs which are not as well defined in Haystack 3 in terms of the reference models.
Got it. Yeah, and I'm assuming you can, whenever the standard gets updated, you guys can just update your model and push updates out.
Yeah, that's the plan.
Cool. Okay. You mentioned the platform aspect of it too. So thinking there's 1,000 different acronyms, but if you think about all the end uses in the building, they have the digital twin platforms coming out where you're pulling in HVAC and lighting and access control and elevators and everything down the line. So how are you guys viewing how 75F connects with those type of platforms? Or are you viewing 75F as that type of platform? Or is it both?
I think it's the last, it's both, right?
Okay.
So obviously we're talking about much larger buildings, right? Class A buildings. So folks who have already implemented what we call a true building intelligence system, or IBS, as sometimes they call it, right? So for those folks, I mean, we would be the authoritative reference source for the HVAC, lighting, and space management.
Okay.
Right? So that's how we look at it. Those are three key parameters that we do good on lighting on the HVAC side, and also space management, figuring out which parts are being utilized. Mm-hmm. And for folks who are looking for other data sources to come in, I mean, we welcome it. I mean, we have a very scalable database model, whether it's just for a building or even for OEMs, right? So the whole piece was that we were originally quite monolithic in terms of our tech stack, but we just launched this in April now. It's a new Renatus version, we call it, and with Athena as our cloud, but it's highly modular, which is what allows the public-private deployments. It also allows for us to work with OEMs who perhaps want just the ML layer, or they want the database layer, right? Or they want just, if you want GPC 36, right? If there's OEMs out there who don't want to run their own version of GPC 36, all they really care about is if they're Haystack compliant, you can just take our algorithms and put it on there. Right? Okay. And our whole idea was that it's not just GPC 36. We want to do the converse as well. If someone's come up with a better way of doing GPC 36 or their own custom way of sequences, right? It's 100% compliant Haystack layer underneath on the hardware side. All you got to do is write an algorithm which uses Haystack.
Got it.
Right.
Okay.
It's as easy as that.
Okay. Yeah. So do I hear you correctly that those three verticals, HVAC, lighting, space management, are you guys planning on expanding beyond that, or could you pull in data from other verticals? Is that kind of where you're headed? You don't have to tell me this, by the way, if this is roadmap stuff. It's
public roadmap stuff. We're definitely pulling in data from other places as well. Right?
Okay.
So the whole point is all about API level integration. I mean, the sky's the limit in terms of what we can do over there.
Okay. And would that include like other legacy BASs? Are you pulling in other hardware to pull into the platform?
we will be soon. We've got some orders, customer deployments where we are going to be doing that. What we're really doing is we're using a backnet to haystack data pump.
Okay.
Right, because that's already commercially available. So rather than us trying to reinvent that whole piece about, so we all just, I keep dissing backnet, but I mean, we are backnet compliant. So we're we're backnet server, right? And we've implemented it just because of that interop. If you are in a larger building and you already have a BAS, which is backnet, I mean, there's no reason that we should be excluded from that, right? So specifically, we go into like a large building, which a tenant might actually want to put us in. So you can go put it in for that one tenant, and then you just expose ourselves using the backnet interface to the rest of the building.
Okay.
Right. So that's a possibility. What we have not done is include direct backnet client functionality. So taking in legacy hardware and trying to integrate it back, because to me, that's a lot of work. It's manual. It goes against the ethos of like trying to make this out of the box.
Yeah, so I think what I'm hearing is if, say, a client has 12 different types of BASs across their portfolio, but then they decide, hey, in this 75F building we have over here, we really like their software layer. I mean, most traditional building automation system software layer is poor, as we've talked about and I've talked about endlessly over the last few months. But what if they say, okay, we really like 75F software and we want to deploy that across all of our whole portfolio without replacing all the hardware underneath and all the other buildings? And they want to do things like standardize their schedules, standardize their set points, standardize their sequences. Is that a direction you guys are headed in? Can you do that today?
We can't do it natively, but we can with the data pump, right? So if they're on backnet, so you would have a backnet to haystack converter, which would allow that first layer of mapping, and then we would talk haystack API to the data pump.
To the data pump. Okay. And so you could send overrides and whatever you wanted to do.
Exactly. Yeah.
Okay. All right. Well, we got about, I don't know, a couple of minutes left here. So I want to ask about services. So how are you guys like going to market today? And specifically, I'm wondering, the BAS service contract is something that I kind of wanted to dig into next for Nexus. And so it's kind of on my mind. And I wonder how you guys are thinking about servicing your hardware and software in a new way.
That's an interesting, I mean, that's part of the whole innovation. So two things that we do is we work with existing control guys or even mechanical contractors to go service their existing customers. We also do work directly with large enterprise customers ourselves directly as well, right? So, but general preference is if it's one-offs, then we would actually go use the same existing service relationship that they have with their service contractor. I mean, we're not here to try to disrupt that piece. What's kind of interesting is because of the fact that we're all IoT and we have our own NOC for monitoring all of our deployments, what we do is we allow the white labeling of the monitoring service. And that's kind of an interesting thing, right? So if you're a smaller shop and you don't have a full NOC, right, you could actually basically get managed services from us, but put it under your own umbrella. So you would end up getting the mechanical contractor or the service contractor would actually end up saying, here's the service contract to their own customer, but we would be providing it, servicing it in the back end. Right. And what's kind of interesting with that is because we have so much data coming in, I mean, we can actually tie back directly and send out service tickets as well to dispatch mechanical guys if needed. So it's an interesting piece in terms of the managed services part, what this allows us to do. So that you can be far more proactive, right? Because the NOC is running all the time.
Wow.
So it's truly a network operating center, which is like looking at all the buildings, looking at all the data and all the alerts which are coming in.
Okay. Cool.
Also, some of our customers, like in some places, it's mandatory to have an engineer on board 24/7 for some critical facilities, right? But they've petitioned cities and counties to get waivers without getting into specific customers, that the engineer only needs to be there during the day shift, and during the evening and the night shift, it actually gets pushed over to the NOC. So we provide the managing and the observation of making sure that the critical facility is running correctly. And in case someone needs to be dispatched, we can do that proactively.
Okay. Cool.
But one of the things that we've had a fair amount of success with is is OEMs of equipment.
Okay.
Right. So you have the big guys, you have the carriers, and you have the trains and JCI who have their own controls. Right. You also have a large number of people who are making HVAC equipment, but who don't necessarily have their own controls line. And for those, I mean, we've really started becoming an OEM out of the box, because now it's a huge differentiator.
Yeah.
Right? No longer do you actually have to rely on someone else to do that system integration, because it's now working out of the box. And so as a package solution, especially for this mid-sized buildings that we're talking about under 200,000 square feet, I mean, it's a huge differentiator.
Totally. What would be an example of a piece of equipment that, you could then just, it comes natively with a 75F controller?
Fuel cooled, swamp coolers, things like AHUs, a lot of customized AHU folks out there, right? Small RTU guys. So we don't do the equipment control, but we provide the building control aspect of it, right? So we wouldn't necessarily go and replace an RTU controller itself, but we would go and interact with that RTU controller and make sure that they basically are making it IoT enabled.
Okay. So a smaller building that only has, 5 RTUs, and then you throw a 75F building controller, and now all of a sudden it has all the intelligence that...
Correct.
Yeah. Okay.
Yeah.
Cool. I love that. All right. So the only thing we didn't hit was on the hardware layer. So I got a couple more minutes as long as you do. So what makes a good hardware layer, since you guys, the same kind of question as earlier, you guys designing it from scratch? How did you approach that?
Biggest thing was all digital, right? Is no sensor is analog. So you look for sensors which are, it starts truly with the sensors, right? You want to make sure that you get sensors that don't require calibration, that don't drift, right? And so if you start with that technology, then you're assured that it cuts down not only your calibration in the factory, but also in the field, and because that's super expensive stuff.
Right.
Right.
Okay.
And so the second thing that we took on is that, in my aspect was that, throw in all the functionality that you think you'll ever need into the hardware right up front. Right.
Okay.
Don't chintz on it. Don't say, hey, can I save this, this small module? And we've got BLE, IR blasters, so much other stuff, which is just out there, and we keep adding new services because it's software upgradable, right? So let's throw in all of the stuff, even if we don't think that we know what we're going to do with it right now.
Got it. And that includes different sensors too, right? Yeah.
Absolutely. Different sensors as well. So now we started, in the new generation of hardware, we've actually started throwing in dedicated CO2 sensors as well, right? Okay. So it's not just derived, but it's those used to be damn expensive, but you're saying that it's not even optional. It's there as part of the product. Every zone, every room, which brings me back, originally I alluded to where 62.1 was. If you go back to where they thought the ventilation rates were, it's purely based on biofluence from human beings, right? Back in the mid-90s, when there was no sensing technology around that. So right. I do believe that at some point we can show accurate data that with intelligent sensing, you perhaps don't need fixed ventilation anymore, as an example.
Got it.
So the hardware layer, in my opinion, is it needs to have all the sensing, all the functionality built in. And the second piece it really needs to do is you want to have a consistent platform. You want to have the same hardware rather than having application specific stuff, right? Because in my opinion, that brings down your cost because you're doing volumes. It allows for more reliability because it's the same product. You're not saying, is CO2 sensor optional? Now, is this going to be for a water source heat pump? Or is this going to be for a heat pump, right? Or is this a fan coil unit, right? I think it changes the supply chain game dramatically. And I think in 2020, that's where we should be.
Got it. Cool. Well, thanks for this conversation. I learned a ton. So thanks for coming on the show.
Thank you so much for having this. I'm glad you're doing what you're doing, James. It's always nice to listen. And so I'm looking forward to the next episode as well, as you said.
Awesome. Well, we'll talk soon.
Sounds good. Take care. Thanks.
All right, friends. Thanks for listening to this episode of the Nexus podcast. For more episodes like this and to get the weekly Nexus newsletter, please subscribe at nexus.substack.com. You can find show notes for this conversation there as well. As always, please reach out on LinkedIn with any thoughts on this episode. I'd love to hear from you. Have a great day.